I am Dr. K.P. Naidu. In this lecture, I am going to discuss about ensemble learning in machine learning. Before understanding about what is different ensemble learning technique, simply first I was given one example. If you're understanding that example, then you can easily understanding the techniques of ensemble learning. So what is meant by ensemble learning means, for example, let us take one assembly segment. If we want to predict who won, which party won in that assembly segment. Okay, let us take, we are having two parties. One party I am taking as, for example, NDA, clear. So another party I can take as, for example, Congress. That is, we are having two parties. Okay, so I want to predict which party won in a particular assembly segment. In a particular assembly segment. So in assembly segment, okay, let us assume we are having 10 villages. Let us assume in assembly segment we are having how many villages? 10 villages. Clear? So from these 10 villages, we are performing some survey, applying some survey. Based upon that survey, we are predicting which party may be win in that assembly. Okay, so from these 10 villages, for example, if we are taken as 5 samples, taken as how many samples? 5 samples. That means let us assume each and every sample contains, for example, 100 collections. How many collections? 100 collections. That means from 10 villages, we are collecting the 5 samples. Each sample contains, okay, 100 persons opinion. 100 persons opinion. That means we are taking as 5 into 100, 500 persons opinion. By taking the 500 persons opinion, which persons or majority give the opinion on the party, that party may won the in that assembly segment. For example, out of 500 persons, maybe some 300 persons may give a opinion, maybe won the NDA. Remain 200 persons given the opinion won the Congress. That means majority persons give the opinion for NDA. That's why the NDA may won the in that assembly segment. Okay, so here how many samples we are collected? 5 samples. Okay, for example, if you are taken clear 10 samples, if we are collecting the how many samples? 10 samples. Again, let assume out of certain samples, out of 10 samples, again let assume each sample contains the opinion of 100%. That means 10 into 100, we are having how many persons opinion? We have got the 100 persons opinion. So from the 100 persons opinion, let assume that 600 persons gives the opinion maybe Congress one, 400 persons gives opinion maybe NDA will won in that assembly. That means majority persons gives the Congress. That means in that assembly segment, NDA may won in that assembly segment. Okay, so that is if you're taking the 10 samples. Okay, let's assume if you are considering the 20 samples. If you're collecting the 20 samples, each sample contains how many persons opinion? 100 persons opinion. So 20 into 100, total we are having 2000 persons opinion. Okay, so from these two persons opinion, let assume 1500 persons gives, okay, gives the opinion may one the NDA party. The remaining 500% may give the opinion may won the Congress party. So the majority percent uh, gives the support to which one? NDA. That means in that assembly segment NDA may won. That means here what we are observing is if you are increasing the number of samples, if you are increasing the number of samples, there may be chance to getting the accurate result, okay, in a particular assembler segment. Compared to 5 samples, if we are collecting 10 samples, we may getting some more accurate result. Compared to 10 samples, if we are collecting the 220 samples, we may getting the more accurate result in that assembly segment. That means if you are increasing the number of samples, if you're increasing the number of samples, there may be chance to getting the more accurate result. Okay, so that is the actual concept we are applying in the concept called as which one? Ensemble learning. What's called as ensemble learning. So ensemble learning means till now we are discussing about different machine learning algorithms. For example, KNN, linear regression, logistic regression, naive-bayes algorithm, SVM. These learning algorithms we are called as the weak learning algorithms. Weak learning algorithms. That means to the given training data, we are building the single model. If you're building the single model, from that model, we are predicting the class of the given test instance. Okay, so let think about to the given training data for the given training data we are combining we are combining 5 different models. For example, to the given training data, I build a model for which one? Using Navy base. I build a model using the KNN. I build a model using, for example, SVM. I build a model, for example, using decision trees. Let us assume. That means to the given training data, I am build a Navy base model, KNN model, SVM model, decision tree model. We are and one more model, let us take for example logistic regression model. That means to the given training data, here we are building how many models? 5 different models. So now if you are combining the 5 different models, so to the given test instance, we are applying on these 5 models. The given test instance, if you are applying on the given these 5 models, okay. For example, the naive Bayes algorithm, it is taken as some binary classification that contains a positive class and negative class. For example, the given test instance, the naive Bayes classifier gives the positive class, the KNN assume given the positive class, the SVM gives the negative class, the decision tree model gives the negative class, the logistic regression gives the positive class. So to the given test instance, from these 5 learning models, majority models gives the positive class. That's why the given test sample belongs to which class? Positive class. That means combining different learning algorithms into a single model, that is we are called as a ensemble learning. Once again, I can repeat, combining different different learning algorithms into a single model. Okay, then that model is called as a ensemble learning algorithm. Here you may get in doubt. It's not necessary that learning model contains different learning algorithms. For example, we may take as two decision tree algorithms, decision tree 1 and decision tree models, two decision tree models, and one, for example, one naive Bayes model. This is also ensemble model. It may contain similar weak learner models or different weak learner models or combination of both combination of both same and different weak learner models. Clear? So now that is the concept of which one ensemble learning. Simply you can understand ensemble learning means combining different weak learning models into a single model, that is called as the ensemble learning. Okay, let us try to understanding what is meant by the ensemble learning. Is a machine learning technique. What it combines multiple individual models. Multiple individual model. That individual model may be a different model, or it may contain the same algorithm, but that algorithm may contain different type of samples, a different subset of training data. Okay, that will be later, that will understand later in the coming slides. Okay, so that combines multiple individual models to create a more robust and accurate predictive model. More, okay, robust and accurate predictive model. That means in ensemble learning we are combining the multiple individual model. From that model we have to get the robust and accurate predictive model. Okay. The idea is that combining the strengths of several model, combining the different weak learning models having some strengths and weaknesses. Here what we can do is we are combining the strengths of different models that can improve the overall performance of the entire model. That is the main concept of ensemble learning. Okay, this ensemble method is mainly used in both for classification and regression. Classification and regression. And one more important is this ensemble method especially works well to solving the problems of overfitting, underfitting, some noise in the data. Okay, so underfitting, overfitting, noise in the data, such type of challenges is overcome by the help of ensemble learning. Okay, this is the one example of which one ensemble learning. This is taken as some training data. Okay, let's take as the population in a particular assembly segment. Okay, so from this population we have taken as one sample, some subset of data from this population. We have to build one logistic model. Again we are taking another subset, that is I am called as a sample, some subset of data. From subset of data, I am building a stream classifier. From this training data, I am taking another subset of data. Here I am taking some random forest classifier. Like this, we are building the different individual models. By combining all the individual models, then we may getting some another model. That model we are called as the ensemble model. That ensemble model gives the more accurate performance. Clear? Why to use ensemble learning means we already discussed. It improves the accuracy. It reduces the variance and bias. That means we know that it effectively works for solving the problems of overfitting and underfitting. That means that ensemble model may having the chance to get the low variance and low bias. That's why it is the best model. And robustness. Okay, it solves the problems of less institutive outliers, noise in the data. Okay, and flexibility. It is works with various types of base models. Various types of base models. That is the for that purpose we are using the which one ensemble learning. Okay, here some of the key concept you have to understanding before discussing about different types of ensemble learning techniques. First one is base learners are also called as the weak learners. The base learners or weak learners are called as the individual models. For example, one logistic model, logistic regression model, or KNN model, or some SVM model, or some naive Bayes model. Those are called as those are called as Bayes models, individual models, weak learner models. That is the key term you have to understand. Diversity. Diversity means we are trying to using different algorithms, okay, and those different algorithms we have to combining, maybe combining decision trees, SVMs, and logistic regressions. Okay, while building these decision tree algorithm or SVM or some logistic regression model or some naive Bayes anything, if you want to training any weak learner model or Bayes model, we have to keep in one mind, we have to take the subset of data from the training data. Subset of data from the training data. That means, for example, if we are having 2 lakhs of records in our training data, okay, from 2 lakhs of records, some subset, maybe for example, some 20,000 records are used for constructing the decision tree. Maybe some from the 2 lakh records, we have taken some again some 20,000 records to constructing SVM model. Maybe from these 20,000 records may having the some of the same records of this previous model records. Okay, that means what you are understanding here is, while we are building these weak learning models, we are taking the subset of data from the training models. Training model subset of data from which one? Training data. By taking the subset of data from the training data, we are to training the models. Okay, so to improving the performance of the model, okay, we are using the different hyperparameters. That means if you are using the KNN algorithm, we are choosing the best value of K. For example, if you are choosing the ID3 algorithm, so what is the maximum height of the decision tree? Okay, what is the metric we are using, as a Gini index or information gain, like that. Okay, for example, if you're building the SVM model, what is the regularization parameter C value, what is the kernel we are using to improve the performance of the model. Likewise, if you're using a different hyperparameter, then there may be chance to get a high accurate performance. Okay, that is the one concept we have to understand. So another important key concept you have to understand is aggregation. What is the meaning of ensemble? Combining the different weak individual models. After combining the different individual models, how to predict the class of the given test instance. For example, let's say as I am combining one naive model, okay, one KNN model, for example, one decision tree model. Combining how many models? Decision tree model. Let us take as it is some classification problems. It is which one? Classification problems. By combining these three models, we are getting one ensemble model. Ensemble model. So, how to predict the class of the given new test instance? Let us assume it is a classification problems of binary classification. The class values may be some positive class and let us assume negative class. What is the class of the given test instance from this ensemble model? First, we have to applying this test instance to the naive Bayes. Let us assume it gives some positive class. Okay, if we are applying the test instance to KNN, it again gives the negative class. If you're applying the test instance decision tree, if you're getting the positive class, means that we're getting which class? Positive class. That means the test instance belongs to which class? Positive class. That is we are called as the voting. Called which one? Voting concept we are applying for which one? Classification. The voting may be hard voting or soft voting. Later we will discuss with example what is meant by hard voting and soft voting. Similar way, average voting, okay, averaging, we are applied for regression. Apply for which one? Regression. Okay, let us assume I am applying for example some SVM. Okay, one more is for example some KNN. Okay, for example one more model is some decision tree. Okay, so regression means the output is numerical value. I am given some input as some test instance to the SVM, to the KNN, some decision tree. It may give some output is some 2.0. It was given some output is some 3. It was given some output is for example some again some 4. So the total output of the entire ensemble model is 2 plus 3 plus 4 by 3, that is 9 by 3, that equals to 3 is the output of the ensemble model, okay, to the given test instance, that is called as the average. Clear? Likewise, we are predicting the class, or we are predicting the output of ensemble model either by using the voting and averaging. One more important is called as stacking, combining the predictions using the meta model. That means we have to using one model to by taking the by combining the some another model. What is meant by metadata? Data about the data. Getting using one model to get the output of the another model, that is called as stacking. That is also we easily understand in the coming slides. Okay. So mainly the ensemble learning methods are categorized into mainly two types, bagging and what is called as the boosting. The bagging is also called as bootstrap aggregating. The best example is random forest. Boosting is, okay, the best example is different boosting algorithms are gradient boosting, ADA boost algorithm, XGBoost, light gradient boost, cat boost. These are all the different boosting algorithms. Random forest is a bagging algorithm. Okay, so what is meant by, what is the difference between bagging and boosting? In bagging, VR models are trained independently. That means parallelly we are trained the models in bagging. Whereas in boosting, sequentially we are trained the model. Sequentially we are trained the model. Okay. So let us try to understand the diagram. This is taken as the bagging. Okay. So keep in one mind while building the weak learner model. Okay, from the training data, we are taking some sample data only. Subset of data from the training data, we are building the model. Here I am building the one model, and I am taking the another sample from the training data. I am building another model. I am taking the another sample from the training data. From that sample, I am building the model. If we are building these three models parallelly, that is called as the bagging. That is called as the bagging. So after building these three models parallelly, combining these three models is called as the ensemble model or ensemble bagging model. Ensemble bagging model. So how to get the output or how to get the class from this bagging model? Let's assume this model gives the positive class to the given test instance. This model, let's assume, gives the negative class to the given test instance. This model gives the positive class to the given test instance. The result is the positive class. That's why the class of the given test instance is the positive class. Okay, but that means in bagging we are using the, we are build the individual models, or we are building the parallel models. We are build the parallel models. Whereas in boosting we are build the sequential model. From the training data we are taking some sample data. From the sample data we are build the one model. By checking the error or the performance, okay, by considering the error or the performance of this model, we are trying to improving the performance of that model by taking the another sample. That means the by taking the outcome of this model, by taking the outcome of this model, outcome of this model. Again we are building the same another model. Again by taking the output of this model, okay, so again we are building the another model. That means some sequentially we are building the model. That is called as the which one? Boosting, iterative weak learners. That boosting means, for example, here I am building the model 1. To improving the performance of this model 1, we are adding some weights. We are adding some weights. By adding some weights, this model may be improved in second iteration. This is the model 2. Again, by adding some weights to this model 2, we boost up. That means by adding some weights to this model, okay, this model may give some weights. Okay, so that means we are building some another model M3. That means the model 3 may gives the more accurate compared to the which one? Model 2. That is the concept of which one? Boosting. In the boosting, we are applying a sequence approach. In packing, we are using the which one? Parallel approach. Another type of model is called as the stacked generalization. Stacked generalized means combining predictions from multiple models using the meta model to take the final prediction. That means, let's see, it may be a little bit of tricky. Okay, we cannot have an exact library in Python to implement in the stacking, but somewhat we are trying to implement in the stacking model by using different functions. Okay, let understand the statement. Using logistic regression to combine predictions from the random forest and SVM. Okay, that means we have to use logistic regression model to combine the predictions from which one? Random forest and SVM. That is, internally it is using the concept of metadata, data about the data. The models about the, again the model. That is called as the stacking. That is called which one? Stacking. The advantages of ensemble learning: higher accuracy, flexibility, adaptability. The drawbacks is obviously complexity. Why? Because we are trying to combining the different individual models. Obviously, it will take the more time. The training time is also takes the more. Why? Because we are trying to building different individual models. Okay. So overfitting, that means somewhat even we are trying to solving the overfitting, underfitting problems of weak learners by using ensemble learning, even though the ensemble learning models may also suffer with the overfitting in some cases. Clear? So these are the real world applications of ensemble learning in finance sector, health sector, marketing, technology, some agriculture sectors, in the various areas in banking sectors, in various areas we are using the which one? Ensemble learnings. So let us try to understanding voting, hard voting and what is called as the soft voting. A simple concept, okay? Hard voting means we are taking uh, the the prediction of each and every individual model, the prediction of each and every individual model out of all the models, which prediction or which class we are given by the majority of the models, that is the final class of the ensemble model. That is called as hard voting. Get the final prediction based upon the majority class predicted by the individual classifiers. Okay, let us try to understand with example. Let us take as we are having the three classes, class 0, class 1 and class 2. That means let us assume it is a multi-class classification problem. How we are applying hard voting to the multi-class classification problem. Let us assume in ensemble model, one weak learner model give the class is 0, another weak learner model gives the class 1 as output, another learning base model gives the class 1 is the output. Result gives the which class? Class 1. That means the class of this entire ensemble model is the 1. majority class. We are using three different base learners, but majority we are getting the class 1. That's why the final class of this ensemble model is the 1. This is example. New instance given to this model, this model, this model, this model. This model gives the 1. This learner gives the class 1. This learner gives the class 2. This learner gives the class 1. Wizard given the which class? Class 1. That is the final class of the new instance is the class 1. That is the concept of which one? Hard voting. Clear? So soft voting means we are having one concept called as the predicted probability. Predicted probability. That means, for example, to each and every base learning model, let us assume it is a binary classification problem. That means we are having two classes, positive class and negative class. To each and every individual model, we are calculating the probability for positive class, probability for no class, probability for positive class, probability for no class. Then we are averaging the probability of all positive classes and probability for all the negative classes. Which probability is more, then that is the probability of the final given, that is the which probability is more, that is the final class of the given new test instance. Okay, so in soft voting the final prediction based on the average predicted probability from all the classifiers, from all classifiers. Let us try to understand. Let us assume it is a binary classifier. Let's take as again we have in the classifier 1, classifier 2, classifier 3. We have to combining these three classifier, that is we are called as the ensemble model. Ensemble model. Clear? So now from the it is binary classifier. From the classifier 1, let us assume it is a what is called as 0 class. It is a 1 class. 0 class and 1 class. So 0 means it may be a false class, it may be a true class. Classifier 1, 70% gives the class 0, 30% gives the class 1. Okay, the class 2, the probability for 0 class is 0.4 for the given new instance. To the given new instance, the probability for 1 class is 0.6. Again, the probability for 0 class to the given test instance is 0.2. The probability for class 1 to the given new instance is 0.8. Okay, so we have to average 0.7 plus 0.4 plus 0.2 by 3, 0.433. What are the probabilities of one class? 0.3 plus 0.6 plus 0.8 by 3, 0.566. We are getting the class 1 having the more value. That's why this ensemble model belongs to a class 1 to the given new test instance. That is the concept of which one? Soft voting. That is the concept which one? Soft voting. The soft voting is applied only to the base learners. To which base learners we are finding the predicted probabilities. Some algorithms may not supporting the predicted probability to the classes. Okay, which algorithm supports the predicted probability to the algorithms? To such algorithms only we are applying the soft voting technique. The key difference between hard voting and soft voting is it uses majority class votes, it uses average predicted probabilities, input class predictions, it is input probability estimates. When to use? When probabilities are unavailable. Okay. When probability estimates are reliable. Strengths: simple, less sensitive to outliers, takes confidence of classifiers into account. This is the difference between hard voting and soft voting. Clear? Now let us try to understand a small piece of code. Okay, later I will explain with in Google Colab all these algorithms. Let us try to understand how to build a one ensemble or ensemble model. Clear? So here I am importing random forest classifier, voting classifier, loss regression classifier, some SVC classifier. from the sklearn libraries. Okay, I'm building one model, logistic regression, random forest regression model, SVC model. That means we're having the three models. From these three models, I want to build one more ensemble model. One more ensemble model. Here I am using the class called as voting classifier. In this we are having some function called as voting classifier function. In this we are having one hyperparameter that is called as estimators. In this estimator we are passing all the base learner models. What is the first model? Log CLF. So log CLF, random CLF, SVM CLF. These three models are combined into which one? Estimators. Here I am using the voting is hard voting. Then we have fit the model, build the model on train data, X train and Y train. Okay. This is ensemble model. This is the weak learner models. That means total having how many models? Four models. Three individual models or weak learner or base learner models. Combining these three models into some another model called as ensemble model. If we are trying to finding the performance of these four models, how we can get the performance? I am passing logistic regression, random forest, SVM, voting classifier models into some for loop. We are taking each and every model one by one. We have to apply the predict function on test data. Then we are finding the accuracy score. Okay, let's see. Logistic regression accuracy is 0.86. Random forest is 0.89. SVS is 0.88. Voting classifier is 0.90. That means the voting classifier gives the more accuracy. That means ensemble model gives the more accuracy compared to the weak learner or individual based models. Okay, that is about ensemble learning, bagging, and what I mean bagging, what I mean the boosting, what I mean by ensemble learning. Okay, thank you.